Now that you know the coordinate plane is made up of 4 quadrants, quadrant 1, 2, 3, and 4, and that points are plotted with x first, we go horizontal, and then y second, vertical, we're going to take a look at plotting polygons on the coordinate plane. So if you are given a set of coordinates and asked, what polygon does this make? Or plot these vertices, remember vertices or vertex just means corner, to create this polygon on the coordinate plane, what do you do? How do you do that? So let's say you're given a set of coordinates, -6, 6. You're also given -6, -2, and finally you're given -2, -2. If you're asked, what shape does this make? The way you would do that is you would take each point and plot them on your graph. So the first one, -6, 6. Starting from the origin, -6 is my x, so I move 6 spaces to the left. And then 6 is positive for my y, so I'll go 6 spaces up, and I'll plot my point. Then I'll go to my next one, -6, -2. Again, starting from the origin, -6, that means I'm going left 6 spaces. And this time my y is also negative, -2. So I'll go down 2 spaces and plot that point. Last, I have a third point, -2, -2. So start from the origin, -2 for my x, so 2 spaces left, -2 for my y, so 2 spaces down. Now I have my 3 points. By looking at them, you might be able to determine what shape this is. The last thing you would need to do then is just connect all of your points with lines. And then you can see I have a triangle, specifically a right triangle. I know that it's a right triangle because there's a right angle here in the corner. Now for another example, let's say you're given 3 points and asked to find the 4th corner. So for example, a problem might say there's a rectangle plotted on the coordinate grid. 3 of its vertices are, and they'll give you 3 of the corners. 1, 5, 7, 5, and 7, -3. They've told you this was a rectangle, so you're going to have to think about the properties of a rectangle when you're deciding where the 4th point will be. That's our task. What is this 4th point? So we'll figure this out by first plotting the 3 points that are given. 1, 5. So start at the origin always. 1 is positive, so it goes right. 5 is positive, so it goes up. Then I'm going to plot my next point, 7, 5. 7 is positive, so to the right 7 spaces. 5 is positive, so up 5 spaces. And I get one more to plot, 7, -3. 7 is positive, so right 7. -3, so down 3 because it's negative. 1, 3. Here are my 3 given vertices. We need to determine the 4th one, knowing this shape is a rectangle. So first, I'm going to connect the points to start making my rectangle. We know something about rectangles. We know rectangles have opposite sides that are equal and parallel, which means if this is one side, there needs to be a side down here equal in length and parallel, so it's not going to be slanted. And then this is a side, there must be a side over here equal in length and parallel. So the equal in length part, we can figure that out a couple of ways. One is simply by counting the boxes. So from here to here, I have 6 boxes. That means this side length is 6. which means this side length down here must also be 6. So I can come from this point here and count 6 spaces over. Now, this side length is 6. So I'm using the properties of a rectangle to determine where that last point goes. Now, once that point is there, I can connect these sides, and lo and behold, I have a rectangle. The final thing I need to determine then is the location of that point. This is the one that we just added in. What is its location? Well, start from the origin. In order to get to this point, I have to go over 1, so that's a positive 1 for the x. And then I have to go down 1, 2, 3. So that's a negative 3 for the y. So the point that we needed to determine is 1, negative 3. If you look at all 4 vertices, hopefully you notice something. Look at the x's. 1 shows up twice. 7 shows up twice. And look at the y's. 5 shows up twice. Negative 3 shows up twice. So that's another way I can check and make sure that I've put the final vertex in the correct location. All right, one more example now with a parallelogram. Similar to this problem, except for instead of being a rectangle, now we're being told, well, here's a parallelogram. Where is its 4th vertex? So a parallelogram, we know opposite sides are equal and parallel. And if we're given this set of points for our parallelogram, we know there's a vertex at negative 5, negative 2. We know there's a vertex at 4, negative 2. We know there's a third vertex at 2, negative 7. And we are in search of that 4th vertex. Where will the 4th corner of this parallelogram be plotted? Just like with the rectangle, we're going to start by plotting the 3 points we know. Negative 5, negative 2, starting from the origin. Negative 5 means go left 5 spaces. Negative 2, down 2. 4, negative 2, starting from the origin. 4 means go right 4 spaces. Then negative 2, down 2. 2, negative 7, starting from the origin. Right 2 spaces. Negative 7, so I'm going down 7. And those are my 3 given points. Again, just like with the rectangle, I can start to connect the sides. I know what a parallelogram looks like. So I can see, oh, this is going to be one side, and this is going to be a side. Again, using the traits or the properties of a parallelogram is going to help me figure out where the last point should go. I know a parallelogram has sides that are opposite, equal, parallel. So if I look at this side, I can again count up the length. I'm choosing this side because on this one here, since it's on an angle, I can't easily count the length. This one though, I can. So if I count from one end to the other of this line segment, I get 9. This side length is 9, which means the side length down here must also be 9. So I can start over here and count over 9 spaces in order to plot my final point. Then it's just a matter of connecting to make my parallelogram. This is the point that I've plotted, so we're going to determine its coordinates. Starting from the origin, how many spaces left or right did I need to move? I moved left, and I moved 7 spaces. Since it's left, it's negative 7. And then how many spaces up or down did I need to move? I moved down, so it's negative, and it's also 7 spaces. Now, one more way that you can figure out where this point would be is if you make yourself a little triangle over here. This should hopefully remind you of when we worked on finding area of parallelograms, and we knew we could cut off this little triangle, place it over here to create a rectangle. Since I know those triangles are the same size, another way I could figure out this missing point, starting at this top corner and counting down 1, 2, 3, 4, 5 spaces and over 1, 2. So then that means to figure out this point that was missing, I could also count down 5 spaces and over 2. So that's another option when you are trying to plot these vertices.